Today's notes are over simplifying non-perfect square roots. So the notes you have might look slightly different than what I'm about to go through, but all of the content is the same. So just follow along and fill in your notes. Let's get started. The first thing that I want to point out about today's lesson is this perfect squares table that's in your notes right here. This is something that we're going to be referring to throughout the lesson, but it's a really good idea to just memorize your perfect squares at least through 15, but I have them all the way through 25. So it's a really good idea to memorize your perfect squares, and today's lesson will also be easier if you know your multiplication facts. But I'll also show you how you can use a calculator to do this. So we're going to be simplifying non-perfect square roots. What is a radical? A radical is this symbol right here. That's a radical. And the different types of radicals are, we have a square root, which there's an assumed 2 right there. You don't have to write that 2 because it's assumed. Kind of like if I put a variable of an x, I can put an exponent of a 1, but I don't have to. It's assumed to be 1. I could also put a coefficient of 1, but I don't have to. It's assumed to be 1. It's the same thing with the square root. When I have a cube root, it looks like that. A fourth root will look like that, and a fifth root will look like that, and so on and so forth. You get the idea. So let's simplify some square roots. Now, all of these on this page are perfect squares. When I take the square root of a perfect square, I get a whole number. So let's look at this perfect squares table. In the left column here, you have a number. If I multiply that number by itself, meaning I square it, I get the number that's in the column on the right. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. You get the idea. So now let's go the other way. If I take the square root of the number on the right, I get the number on the left. So if I take the square root of 1, I get 1. If I take the square root of 4, I get 2. The square root of 36 is 6. So if I square the number on the left, I get the number on the right. If I take the square root of the number on the right, I get the number on the left, which means they're inverse operations. They undo each other. So the square root of 25 is right here. It's 5. The square root of 64 is 8. The square root of 100 is 10. The square root of 49 is 7. The square root of 81 is 9. The square root of negative 25, well, wait a second. If I take 5 and I square it, which let me write this down. If I take 5 and I square it, I get 25. If I take negative 5 and I square it, I also get 25. So can I take the square root of a negative number? The answer is no. So this is not a real number. When you get to Algebra 2, you'll learn about imaginary numbers, and so you will rewrite that. When you get to number 7, let's see, the square root of 1, that's 1. And then now let's look at what we do when we have fractions underneath our radical. If our numerator and our denominator are both perfect squares, I just take the square root of each. So the square root of 9 over 100 is going to be 3 over 10 because the square root of 9 is 3 and the square root of 100 is 10. On number 9, the square root of 36 over 121, again, both are perfect squares, so the square root of 36 is 6 and the square root of 121 is 11. So these are just examples of our perfect squares. So that's the easy part. Let's get into the next part, which is simplifying our non-perfect square roots. So go to the second page, and again I have this perfect squares table because it's a really good table to reference when you're just first learning about simplifying non-perfect squares. So here's the process. I'm taking the square root of 32. This is number 10. I notice that underneath that radical is a non-perfect square. It's not one of these in this column in my table.
When I simplify a non-perfect square, now in middle school, you might have just plugged it into your calculator and rounded to the nearest hundredths place or something like that. We don't do that in upper level math. We simplify it into non-perfect square roots, and it's just a way that we can write an exact answer. We aren't rounding, so it's perfect. It's exact. So the square root of 32, what I'm going to do is I'm going to find the square 32, I'm going to find the two perfect squares in my table that 32 lies between. It lies between these two perfect squares. And then I'm going to find the biggest perfect square that is a factor of 32. Now, what does that mean? To be a factor of 32 means that it goes into that number a whole number of times. 32 is divisible by this number. So I can use my calculator to do this if you don't know your multiplication facts. What I'll do in my calculator, I'll do 32 divided by 25, and I'll get a decimal. So it's not that one. 32 divided by 16. Oh, what do you notice? When I plug 32 divided by 16 into my calculator, I get 2. So I'm going to write this. If 16 times 2 is 32, then the square root of 16 times the square root of 2 is the square root of 32. I can also write that like this. I'm going to write it up here. The square root of 16 times 2. But I like to write it like this. And the square root of 16 times the square root of 2. And now, what is the square root of 16? It's 4. So what I'm going to do is rewrite. If the square root of 16 is 4, I'm going to cross out the square root of 16 and I'm going to write a 4 there. So really this is 4 times the square root of 2. And I write it like this, 4 square roots of 2. And I've seen some older guys say it 4 root 2. If I were to plug in the square root of 32 in my calculator, I'd get a decimal. If I plug in 4 square roots of 2 in my calculator, I get that same decimal. It's the same amount. It's just like when I take 16/20ths and I simplify it. Well, what could I do? I could simplify it to 8/10ths, but it's not all the way simplified. If I simplify it to 4/5ths, there, I've simplified my fraction all the way into its simplest form. This is that in square root world. Okay, so let's do the square root of 98. So I'm going to erase this off of my perfect squares table. And I'm going to go to where 98 is. It's not letting me erase that. There we go. 98 is on my perfect squares table. So here's right here. Those are the two perfect squares that 98 falls between. So I'm going to find the biggest perfect square that goes into 98. So 98 divided by 81. Nope. 98 divided by 64. Nope. I'm getting decimals when I plug those into my calculator. 98 divided by 49. Ding, ding, ding. 98 divided by 49 is 2, which means the square root of 49 times the square root of 2 is the square root of 98. What is the square root of 49? It's 7. So I really like to write my perfect squares first because that's the one that I'm going to rewrite. That's the one that I'm going to cross out and rewrite it as a 7, and then the square root of 2 stays there. It stays underneath the radical. Okay, so 7 square roots of 2. Let's go to number 12. Since this is a brand new topic, a lot of students really struggle with this on day one, at least with the first several examples, and then all of a sudden a light bulb just goes off, just clicks. So the square root of 12, I'm going to find the two perfect squares that 12 lies between. It lies between 9 and 16, and I'm going to find the biggest perfect square that goes into 12. 12 divided by 9? Nope. 12 divided by 4? Yep. 4 times what is 12? 4 times 3. So the square root of 4 times the square root of 3 is the square root of 12. What is the square root of 4? It's 2. So I'm going to rewrite this as 2 square roots of 3. Let's go to number 24, and I think I'm going to switch up my color just because I want to. And let's go to number 13. So on number 13, I've got the square root of 24. So I'm going to find the two perfect squares that 24 lies between. It lies between these two perfect squares. And if you want to pause this video right now to practice finding the biggest perfect square that goes into 24, you can do that now. So the square root of 24, 16 does not go into 24, 9 does not go into 24, 4 does. That's the biggest perfect square that goes into 24. So the square root of 4 times the square root of 6 is the square root of 24. What is the square root of 4? It's 2. So 2 square roots of 6. I know this is simplified the most that it can be simplified, right? That's our ultimate goal. It's got to be simplified the most it can be simplified. Kind of like if I go back to my fraction example, 8/10 is a simplified fraction of 16/20, but it's not the most it can be simplified. 4/5 is. That's the answer that we're wanting to get to. So 2 square roots of 6. This number that's underneath the radical, it's called the radicand. If that number is not divisible by any other of these perfect squares, then you're good. It's simplified the most that it can be simplified. So let's go on to number 14. Square root of 63. I'm looking at right here in my perfect squares table. The square root of 63, I'm going to go up my table of values to see what perfect square goes into 63. The biggest perfect square, 49 doesn't, 36, nope, 25, 16, 9 does. 9 times what is 63? 9 times 7. Now, a lot of students, if you know your multiplication facts, you might be thinking of these factors first when you think of 63. When I think of 63, I always think of 9 times 7. I know when I'm just starting there that 9 is going to be the biggest perfect square that goes into 63 because 7 is prime. What does that mean? What does prime mean? It means the only factors that go into 7 are 1 in itself. You remember these T-charts that you used to do? I guess they look like this. 7. The factors of 7 are 1 and 7, and that was it. Or maybe you did the rainbow. 1 and 7. Connect them, draw your rainbow. When you had factors of only 1 in itself, that meant it's a prime number. It's not composite. There are no other numbers that go into it besides 1 in itself. So if I've got a prime number as the other number, that's definitely the biggest perfect square that goes into it. So what is the square root of 9? It's 3. 3 square roots of 7. Let's go on to number 15. 150. Again, I'm just doing this the same way every time. You might find little tricks to make it faster, but I'm just going to be consistent and do it the same way every time. So 150 is right here. When I go up my table of values to find the biggest perfect square that goes into 150, you can pause this video and do that now if you'd like, but I'm going to give you the answer. It's 25. 25 times what is 150? 25 times 6, which means the square root of 25 times the square root of 6 is the square root of 150. What is the square root of 25? It's 5. So 5 square roots of 6. That's my answer. This perfect squares table comes in handy, huh? You can always make one. If you're not allowed one on a test or something, you can always make one. It's really nice to refer to. So square root of 245. Let's figure out the biggest perfect square that goes into 245. So I'm going to look right here. 245. And let's see, 245 is right here. I can write it just like this. And really, if I'm going up my table of values, half of 245 is 122.5. So I know none of these are going to go into 245 a whole number of times. Some of you may have already gotten to that point, but I can absolutely do that to help me out. 100 I know doesn't. Okay, so when I, obviously the multiples of 100 are 100, 200, 300. So when I'm plugging in 245 divided by 81, nope. 245 divided by 64, nope. 245 divided by 49, oh, what do you notice? 245 divided by 49 is 5. So 49 is the biggest perfect square that goes into 245. And the square root of 49 is 7. So I can cross that out and rewrite it as 7 square roots of 5. And let's look at number 17, the biggest perfect square that goes into 72. Sorry about that. Where is 72? 72 is right here. So 72 divided by 6. Nope, nope. Looky there. It's 36. The square root of 36 times the square root of 2 is 72. What is the square root of 36? It's 6. So 6 square roots of 2. Last one in this section, the square root of 8. So again, I'm just going to erase this. And if you don't want to write all over it, you don't have to. You can just kind of lay your pencil right next to it and go up your table of values. So the square root of 8, let's see, it's right here. So really my only option is 4, and guess what? 4 goes into 8. How many times? 2 times. Square root of 4 times the square root of 2. What is the square root of 4? It's 2. So 2 square roots of 2, and that's my answer. Okay, let's go on to the next section, and we're still going to refer to this perfect squares table when we go through these examples. So in all of these examples in this next section, there is a number in front of our radical. So I'm just going to add one little step. I'm really going to do all of the same steps I just did. I'm just going to tack on one little step at the end. So here's how I like to do this. The square root of 8. Now I actually just did that on number 18, so I know the square root of 8 is 2 square roots of 2, but I'm going to do this the same way that I did all the others. So the square root of 8, the biggest perfect square that goes into 8 is 4. So the square root of 4 times the square root of 2 is the square root of 8. What is the square root of 4? It's 2. So I'm going to rewrite this as 2 square roots of 2. Notice though that there was a number in front right here. It was a 5. You're going to take these two numbers that were on the outside and you're going to multiply them together. 5 times 2 is 10, so it's 10 square roots of 2. Because when I read this 5 square roots of 8, that means 5 times the square root of 8. So if I simplify the square root of 8 and get 2 square roots of 2, then it's really 5 times 2 times the square root of 2. So I can just multiply 5 and 2 together, and that's all we're doing today in this section. Okay, let's go to number 20. 3 square roots of 28. So when I look at 28, 28 falls between these two perfect squares right here. When I go up my table of values, the biggest perfect square that goes into 28 is 4. So I'm going to break this out into the square root of 4 times the square root of 7. Because the square root of 4 times the square root of 7 is the square root of 28. What is the square root of 4? It's 2. 2 square roots of 7. But again, I've got that number in front that I need to multiply. 2 times 3 is 6. 6 square roots of 7 is my answer. Let's go on to number 21. 4 square roots of 20. I need to simplify it the most it can be simplified. So the square root of 20. That lies right here in my perfect squares table. The biggest perfect square that goes into 20 is 4. Well, 4 times what is 20? 4 times 5. So the square root of 4 times the square root of 5 is the square root of 20. What is the square root of 4? It's 2. So 2 square roots of 5. But don't forget, I've got this number in front that I can multiply this by, and I'm going to get 8 square roots of 5, or 8 root 5. Again, if I'm going too fast or too slow, you can always pause it, fast forward, whatever you need to do to get the lesson. The main thing is just that you understand it by the end of it. Okay, let's go on to number 22. The square root of 32. So the biggest perfect square, let's see, 32 lies right here in my perfect squares table. The square root of 32, the biggest perfect square that goes into it is 16. Well, that's the square root of 16 times the square root of 2, because 16 times 2 is 32. What is the square root of 16? It's 4. So 4 square roots of 2. And then I need to multiply it by this number that's out in front. 4 times negative 3 is negative 12 square roots of 2. And that's my answer. Looking at number 23. Negative 7 square roots of 50. So I need to simplify the square root of 50 first. Obviously, I'm thinking 25, and that's definitely the biggest perfect square that goes into 50. The square root of 25 times the square root of 2. What is the square root of 25? It's 5. 5 square roots of 2. But again, I've got that number out in front, so I need to make sure that I multiply those together, and I get negative 35 square roots of 2. Let's do number 24. Number 24, well, what do you notice? 100 is a perfect square. So 2 times the square root of 100 is 2 times 10, which is 20. Well, that was pretty simple. Okay, let's go on to our final 3 problems. And I'm just going to zoom in, and you can refer to your perfect squares table. 15 square roots of 24. So the first thing I'm going to do is simplify the square root of 24 and find the biggest perfect square that goes into 24. And it's 4. Well, 4 times 6 is 24, so the square root of 4 times the square root of 6 is the square root of 24. And then we're going to simplify only the one that's the perfect square, which is the square root of 4. It's 2. So I'm going to rewrite it like that. But because I had that number out in front, I need to multiply 15 times 2 to get 30 square roots of 6. Looking at negative 5 times the square root of 108. The biggest perfect square that goes into 108 is, if you want to pause this video and try that now, I would suggest it. But the biggest perfect square that goes into 108 is 36. 36 times 3. So the square root of 36 times the square root of 3. What is the square root of 36? It's 6. You see what I mean by if you know your perfect squares, this is much, much easier. And don't forget, I've got that number out in front that I need to multiply only the number on the outside by. Negative 5 times 6 is negative 30 square roots of 3. And let's do our last and final problem. I've got 3x times the square root of 175. So I need to simplify only what's underneath our radical. And the biggest perfect square that goes into 175 is 25. 25 times 7 is 175. Therefore, the square root of 25 times the square root of 7 is the square root of 175. What is the square root of 25? It's 5. 5 square roots of 7, but again, I've got this term on the outside, which I'm just multiplying it by. So 3x times 5 is 15x square roots of 7. And that concludes your notes over simplifying non-perfect square roots.